Hello everyone, and welcome to a comprehensive presentation of the research, experimentation, and results that went into completing a project focused on utilizing Palo Alto next-generation firewalls to implement application identification policies. Completed by Heather Howe and myself, Karis Greer, with supplementary guidance and direction from advisor Samia Chiori. We hope you enjoy this brief description and visualization of the strategies and techniques used to accomplish our project's goal. Our presentation agenda includes the following: an abstract overview of the project's origin and its significance, a detailed description of the tools and features of the next generation firewall utilized for our task, background information on the protocols, devices, and features highlighted throughout the presentation, an overview of the client test environment where the project was conducted, screenshots and in-depth explanations of the protocols employed during the experimentation phase, a summary of the final results showcasing the effectiveness of our application identification procedures, and a comprehensive conclusion to wrap up the presentation. Our project focuses on demonstrating the configuration of a next-generation firewall to effectively identify and control application-specific traffic using application identification, also called App ID. App ID is a feature that enables the recognition of traffic patterns associated with various applications and services. This ranges from general activities linked to platforms like Google to their more specific sub-applications such as Google Maps. The next-gen firewall provides a level of granular application awareness that traditional firewalls lack. By implementing app-level policies, the next-gen firewall ensures precise control over diverse network traffic. Unlike traditional methods that rely solely on ports and protocols, this advanced approach allows the firewall to interact with traffic at the application level. For example, while open ports like HTTPS are essential for communication, they are also prone to exploitation. App ID mitigates such risks by focusing on the specific application rather than the port itself. The objective of this project is to assess and demonstrate the accuracy and effectiveness of the next-gen firewall's application identification capabilities, showcasing its value in enhancing security and traffic management. This project highlights how Palo Alto's next-gen firewall uses App ID to enhance security by identifying, classifying, and controlling applications at the Layer 7 application layer. Unlike traditional methods, App ID focuses on application behavior rather than ports or IP addresses. We configured and tested App ID rules to manage specific applications like FTP and created application groups such as Palo Alto Networks DNS Security for granular control over sub-applications. Additionally, the NGFW detects shadow rule conflicts, ensuring policies are applied correctly. This project demonstrates how App ID optimizes traffic management and strengthens network security by allowing or blocking applications based on organizational needs.
Before we continue, I will explain the terminology used in this presentation. A firewall permits or denies network traffic based on security rules set by the firewall's administrators. A traditional firewall permits or denies traffic based on its source or destination IP addresses and port numbers. However, a packet's destination port number, in particular, may not always be an accurate representation of its contents. An application is a specific program or feature whose communication can be labeled, monitored, and controlled. Some applications must be allowed for an organization to operate, while others may need to be blocked. The Palo Alto Network's next-generation firewall we are demonstrating in this presentation uses App ID to determine which application the packet actually originates from in order to make filtering decisions. Which applications are allowed or denied can differ based on security zones or segments of the networks with their own security policy rules. Applications may also be placed into groups for ease of configuration. Test system we used in this project include a DMZ server, a client end device, a virtual router, and a switch. The topology comprises three zones: the user's net, representing the devices in the organization's headquarters, the extranet, representing the DMZ, and the external internet zone. Different security policies are applied to different zones, so that, for example, traffic between the user's net zone and internet zone is more restricted than between the extranet and internet. Next, I will explain how we create an application group in order to explicitly permit select traffic between the internet and the user's net. The firewall is in the user's net zone at 192.168.1.254. To ensure that it can access the Palo Alto Network's update server and related services, we first configured an application group, Palo Alto Apps, containing 5 relevant application types. We then create a security policy rule that allowed traffic from the Palo Alto Apps application group when the source IP address is equal to 192.168.1.254, the firewall, in the user's net zone, and the destination is the internet zone. Finally, we modified the users to internet rule to prevent rule shadowing. With this modification, only traffic that matches the applications listed in the users to internet or Palo Alto apps rules are allowed to communicate between the user's net zone and the internet zone. Now I will demonstrate the rules in action. I'm generating traffic by visiting the Palo Alto Network's homepage like this. Here, I'm loading the traffic log filter for all traffic from this client, 192.168.20, that hits the users to internet rule. Here I am applying it. Here you can see applications that are allowed like DNS and SSL, and you can see that the filter is only showing traffic from this client right here.
I'm going to talk about some of the results that we got from these labs. The results indicate that traffic from allowed applications is permitted as configured, generating traffic to the Palo Alto update server by having the firewall check for updates created entries in the traffic log. Using these log entries, we were able to verify that the traffic between the firewall and the update server was allowed, and that it was specifically the allow pan-w apps rule that allowed the traffic to go through. We can see in the action that it says allowed, and in the rule column, we can see that it was the allow pan-w apps rule. By restricting the users to internet rule to only allow DNS, SSL, and web traffic, we used the rule of least privilege, permitting only essential network traffic. We then observed that traffic be identified and allowed through the firewall in the traffic log, verifying that App ID could accurately classify applications and apply policies based on specific requirements. We can see in the traffic log below that this shows that the DNS and SSL traffic is being allowed through the firewall using the users to internet rule in the rule column. To finally continue, our results validate that the next generation firewall and its App ID capabilities and security policy features were configured effectively, providing evidence that with App ID, the firewall can uphold security measures while allowing necessary selective network traffic. In a final conclusion of our project, as demonstrated by the completion of this project, we have successfully configured App ID-based traffic filtering rules on the Palo Alto Network's next-generation firewall, significantly enhancing the firewall's security posture by providing more detailed traffic control as compared to traditional port-based methods. By creating application groups and security policy rules, we allowed only specified application traffic between an internal zone and the internet. Overall, we were successful in managing and logging network traffic on an application level.